joining in, be continuing from where we left off, right? So in our previous sessions, we have learned a lot about conditionals and also how inference happens. Okay, so the people who have joined recently, first let me go ahead and give you a map of how and where we are right now, correct? How we are proceeding and where we are right now. Like Tejinder sir, thanks for joining in. So these particular revision hackathons are a repeat or revision of the actual sessions done by the primary faculty here, either Jain sir or Rajiv sir, right? So if at all you have joined recently, if any one of you have joined recently, like Tariq, Tejinder sir, so what you can do is you can go ahead and watch it from the beginning. You might already be beginning your journey, but you can even still continue the session to understand the overview of it, right? So I request you to at least finish 1 or 2 modules by self. So let me go ahead and share my screen, right? Okay, so I hope my screen is available. Let me share it. Okay. Great. Amazing. Yeah. So now if at all you look at the course that you have on your Teachable, you'll be able to see that these are the sessions, right? So these are the lectures. First is Introduction to Python Programming. So, and you can go through that. If you have recently joined, you can go through each of the sessions, right? So individually, and there are also other resources that are being shared here. So once you complete this, then we have the EDA, make features, all of these. So every revision hackathon was a revision of each of the individual lectures, right? So we revised 1.4, we revised 1.5. Similarly, we continued on to 2. Right now we are in statistics. We have completed our t-testing. We have completed our chi-square tests, confidence intervals, right? So now today we are going to cover this Bayesian statistics, right? So this is how we are going forward, right? So if you understood how the it is all mapped out, right? Type U in the chat box, especially the people who have joined recently, because this is how it goes. For example, if you want to begin from the start, you can start doing that, because very much the revision is a repeat of the same, right? Okay, great. Thank you so much. Thanks, Prashant. So people who are watching us on our social channels, you can use the comments and chat section to let us know. Okay, yes, Ridesh. Great. So now today's lecture, if you go to your Bayesian statistics lecture, you'll be able to see that once you click on the video, you'll be able to see that this is the lecture that comes in. Right? So we're going to revise the same concepts. For that, I'm going to share the link. So you might have to copy, duplicate the link, the collab file, right? Yeah, so this is the collab file. I'd request you to open this on your, one of the tabs, right? So if at all you're joining for the first time, you can definitely go ahead and open, because Tejinder sir, I think we have together worked on how to initiate your collab, right? So you can open the collab and you'll be able to run it, right? So only thing that you might have to do is you can click on file and maybe say save a copy in Drive, and then it'll open in a new tab, right? So you can go ahead and run it from there. Okay, so let's dive in. I'm going to share. We'll try to understand what is Bayesian inference and a little more about Bayesian theorem, right? Bayes theorem. Okay, so give me a second. Amazing. Now, if you go ahead, the objectives of today's session, we'll be using conditional probabilities and understand the mathematical notation associated with them, and we'll use Bayes theorem to iteratively update or understand a prior probability, right? Okay, so what is inference? We have understood in our previous sessions. We have understood statistical inference. Inference is your way to generate an insight based upon the method, right? So we use this theorem called Bayes theorem. We'll understand more about it, right? So if you want to just briefly understand it, this is a way to understand probability of an event occurring when given some other event occurs, right? So let me give you an example. Even Jain sir in the lecture explains that, right? So for example, if A is an event where India is going to win, and then B is an event where we have Virat Kohli hits a century, right? So if the question is like this, right? What is the probability of India winning when Virat hits a century, right? So you have a few unknowns and a little data, right? So what kind of data you have? You have data that how many times India won when Virat hit a century, right? So you have a little data, and out of that you can generate statistical inference or the Bayesian inference here, which will tell you what is the probability that India is going to win when Virat hits a century, right? So basically it will give you an deeper understanding where people who have joined just now, you can go ahead and mute, so that will be easier for us. Thank you so much. So this will be easier for you to be sure, like maybe within mind you'll be able to plan, like, okay, the chances of us Virat hitting a century today and also winning is, let's say, 50%, 40%, 30, 70. So I'm just giving you a random. So you'll have a little more clarity and assessment, right? So that is how this works. You no longer have to guess, right? Maybe there's no maybe, so you can actually infer that, right? So if you have understood the overview concept of what is that we are going to do today, what kind of events probability you will actually be able to assess, right? Given other events. If you understood the whole of it, or the overview, we'll go deeper. If you understood this, type U in the chat box. Thank you, Suraj. Yeah, so people on the social channels, yeah, thank you, Vinita. Thank you, Ritesh. Thank you, Anita. Now, so we'll proceed forward. Thank you, Praveen. Now, we'll also see this is also widely used in machine learning, algorithms. Also, we'll learn about it as we proceed forward. This is also used in Bayesian hyperparameter tuning, which is more commonly used in neural networks and complex machine learning algorithms. So we'll come to that later. So you can just understand why is the necessity for learning this, because it is used widely in other popular and important areas. So that is the reason understanding this becomes important, right? So we'll also know how to optimize it and a lot of other cool stuff, right? Now, as we proceed, so one of our objectives is using conditional probabilities. So what is basically conditional probability? What is that? So basically now, let's say if there's a coin toss, now you know that the probability of it either being heads or tails is 50%, right? So you know the probability. Similarly, now if you want to do also match it with another condition. Okay, so let me just check if my audio is still. Okay, it should be better now, right? So basically, you know what is probability. Now, conditional probability is for you to know the probability of an event occurring given other events or other conditions, right? So we'll try to understand it a little bit deeper, right? Now, what is conditional probability? In module 1, lots and lots of rules of probability. We're going to talk all about it. So how many of you have the Collab file open? Type O in the chat box, because I don't want you to just go through the screen. Yeah, so I want you to run it. Yes, thank you so much, Rupesh. Thank you, Suresh. Thank you, Gopal. Thank you, Sivakumar. Thank you, Neeta. Great. So now, let's say there are two events, right? Try to visualize it with the same. Praveen Kumar says not running. Not running is the file not running or you are not running. So I request you to go ahead and do it, open it. Though if at all, just if you have just joined, then maybe that is the only case where you might want to start from the beginning, but try to understand it also as parallel. Thank you so much. If there's any challenge, Praveen, we're here to help. Even if you have a query in previous any of your...
It's open.
Yeah, please go ahead.
It's not saved. It's open. It's not saved. I tried to save it. File is not saved.
Okay, but it is running. Did you like, how do you know how to run? You'll have to click on this run option. Okay, so now...
Okay.
I think I understood it. Now, once you open, you click on the file.
Just a minute.
And click on save a copy in Drive. Yeah, so others, please bear with us like here. These hackathons are actually to help. Like if you have any query, any of you have a query in previous, any of your lectures, you can bring your queries towards the end, right? So we'll try to work them out, or, you know, we'll understand them more in our upcoming sessions also. So, Praveen, we are here. So let us know what you have to do.
Okay, sir.
You're able to save, click on save a copy in Drive. To do that, it'll ask to open in a new tab.
Yes.
Yeah, so now it will run, right? So when you first run here, it will, then after that, you'll be able to run. So if you have any problem, you can put it in the chat also to mark it everyone. So if not, me, anyone else also will be able to help.
Okay.
Yeah, and even others also. I hope you're on Mighty Networks. Any challenge you're facing, I'd ask. Yeah, I'd ask everyone to also use Mighty Networks to, because the whole community there. Any small or big, you can go ahead and. Okay, so questions, not a problem. I've just shared that link to everyone. Before you joined, you missed it, right? But I would request that the people who have joined now to mute. I would request. Okay, right. Thanks. Now, but you'll not be in a session every time for the collab file. So you can always go to the lecture. You can see that there is an option for download the collab file. So when you click that, it will open, and then you can click on open with Google Colab and it will open up. Yes. Okay. So Rajamurthy said you will require the link to the Mighty Networks in your email, right? So if that is not, you can always, should not be a problem. I'll help you out. Okay. So towards the end, I'll help you join the Mighty Networks. Great. Okay. Thanks. So let's begin. Okay. So I'm going to use sheets like how Jayan sir does it in this session. I have just opened, let's say, okay, so what I'm going to do, I'm going to help you understand this, right? So there are two events. Visualize this with the example that I've said, right? So probability of India winning, and also given that Virat hits a century, right? So probability of A given B. So now when you say this, pipe symbol, this single straight line, this is called pipe symbol, and it is also read as probability of A given B, right? So it's like that. Now, and it says, the formula goes like this. It says probability of A and B. So this is an intersection. So the probability of the event happening when both happen, right? Both events happen, right? So the probability of A happening given B, India winning when Virat hits a century, is the probability of India winning and Virat hitting century. Like you'll have that data, right? So you can just go ahead and assess that, and then divide it by probability of Virat just hitting a century, probability of B, right? So we'll understand this with an example as we proceed forward. But if you've understood the notation, so this is how it is, right? It says probability of A given B is probability of A and B happening together by probability of B. So if you've understood this, type U in the chat box. Great, thank you, Ritesh. So this is, so people who have not received the link to Mighty Networks, I'm going to help you out. Thank you, Suraj. Thank you, Ritesh, Vinita, Gopal, Rajaskar, Anil, and Sivakumar. Great. Now, so we're going to use our pandas and NumPy. We're going to import it. Click on this. Then there is this data. So we are going to use the Titanic data set. We have previously seen our data set. We are going to work closely with this particular data set, right? So, people who have joined recently, we are going to import any data set in this particular way. But if you see our previous lectures, you'll understand deeply also, right? So what I'm going to do here is I'm going to create a variable, which is a data frame. And in that, I am going to load this particular data. So whatever data I've shown, I'm loading it into this particular data frame, and I'm going to see what is there within that particular data frame. So how do you do that? You say df.head. So the name of the variable .head, which will give the first 5 observations from that particular data set, right? So you can see that because it's a Titanic data set, it is telling us if this person, let's say Mrs. John Bradley, she survived and she was in the first class, gender, age, and then what is the fare that she has paid, right? So all that data is there in that data set. Now whole of the data set is in the data frame. Cool. Yeah, so basically Ritesh's question is, are these two dependent or independent events? Yeah, so basically the question is, by the example, if you see India winning and Virat hitting a century, both of these are independent events, right? So without Virat hitting the century, also India can win, and Virat can hit a century without India winning. So I think the question becomes easier to understand when you visualize it with an example. I hope that answers your question, Ritesh. Great. So now we have our example Titanic set. Okay, so I'm going to reconnect because I would be in idle here. Now I hope I've run this. So now when you run this, you'll be able to see the data frame, right? Now I'm going to click on edit, clear all outputs, so it becomes easier for you to understand. I'll run it parallelly with you, right? So now let A be the event of surviving the sinking, right? So there are here, what is that we're trying to assess, right? So in this particular data set, let's see the probability of survival for a passenger on a Titanic given the gender, right? So what are we trying to do? Let A be the event of surviving the sinking and B be the event of the person being a male passenger. So we are doing 2 events, right? So one, the event A is a person survived the ship sinking, and B is the event of that person being male, right? Okay, so let me see if I have the link. So maybe Ritesh, can you help Praveen sir by sharing the link? Great. Thank you so much, sir. Now, if you can see the probability of A given B. So what we can do here is the probability, what is that we are trying to understand here? The probability of a person being surviving the sinking and he being male is equal to person, the probability of surviving and being male, so which is A intersection B, and thank you so much, Ritesh, and the probability of the passenger being male, right? So let us try to understand this here in the Excel sheet here, right? So what is that we are trying to do? Probability of A given B, right? So A given B is probability of surviving given the passenger is male, right? So now probability of A intersection, right? So here, A, I'm going to say and B, which is intersection, right? Probability of A and B happening together is probability of surviving and passenger is male, and probability of B is probability of passenger being male, right? So now we're going to assess this. Okay, so now a few of them are easily understandable. So how we are going to do now, if you look at one thing that we have done in our previous sessions is cross table, right? So what crosstab does is it gives you a table with the survival or any two columns, right? Did he survive, not, and what is his gender, male or female, right? So this is how the syntax is. I think crosstabs is something that you have to have it, remember it, because it's a very useful one. So I'm going to do here crosstab of the data frame with column, the gender, sex, and the data frame, the column survived, margins as well. Okay, so I'm going to run it. So people who have joined this and like just now, I would request you to mute. Yeah, so now what Crosstabs has done, it has given us if the person is male or female and if they survived or not, right? So 81, how do you read it? So people who did survive and people who were female is 233 people, and people who did survive and who were male is 109 people, right? Similarly, who did not survive and male were 464 and did not survive and female were 81, right? And it does the sum of all survived, all did not survive, and all female and all male, right? So now if you see probability of B, right? So a person being male is the total male passengers on the ship by the total passengers. So we had 887 passengers on the ship, and the probability of a person being male is 573 by 887, right? So if you understood this, the probability of the person being male, type U in the chat box. Very simple, right? Thank you, Ritesh. Right, so I'm going to run it. So we did it simply like 573 by 887, right? So now how did we do that? I'm going to copy this cross table here, and I'm going to do equal to passenger, the probability of passenger being male. So it is all males divided by all passengers, right? So this is 0.64. Great. Okay. Now we have come here. The cross table helped you assess, and here we have done it. We use the numbers and got the probability. Now we need an intersection, the probability of A and probability of B, right? So this is the variable, and now you want to see the person, like what is the event A? Event A is survived and event B male, right? Now if you come to your data set, survived and male, so we can see 109 here. So you can see how crosstab is very helpful in trying to do when you're trying to do A intersection B or A B intersection A, right? So if you now know people who survived and people who were male were 109, right? So similarly, what we are going to do here is 109 divided by 887, because that is the intersection, the male passengers who survived. So probability of surviving and being male equal to 109 divided by 887, right? And similarly, sorry, let me close this. Now let's go ahead and print that. So this is how you print. People have joined recently. We are just doing simple math here, right? So we're trying to understand the Bayesian, logic here, the theorem's logic and individual variables. So not worry about it. We are just dividing them and then printing it. Now you can see that 0.12 is the probability of the person being male and surviving, right? Thank you so much, Raja. Okay, so now we've understood these numbers. Now, what do we have? We have we need probability of the person being surviving and male, which is equal to probability of A intersection B by probability of B. So if we do that, which is equal to probability of A intersection B divided by probability of B, right? So which is 0.19, which is 19%, right? So now if you do that, you're going to get the same here. So it is 19%. So let's just say now you have some insight. So what did you infer out of this, right? So you got the logic. We use the same formula here, which is probability of a person surviving and being male is equal to the probability of both happening and just probability of being male, right? So now what do we know here is, if the Titanic event was they happened, and given all circumstances being same, let's just say the iceberg being there and everything happening same as it is, like in a hypothetical case, and there's a person getting, like a male person getting onto the ship, right, by at the ticket time. If you can go back in future or back in the past, or tell a similar event is happening in a hypothetical case, you can say the chances of a male, you can say if it's a male you're talking, you surviving is 19%, right? So now that is the inference. I'm just giving you understand. So now, did you understand the whole example and how this Bayesian theorem helped you in understanding something that you did not know, given you had other inputs? If you understood this, type U in the chat box. Yeah, so now this was a previous past example. We'll go ahead and see actual ones. Yeah, so Ritesh asked, because so Praveen, I think the confusion could be genuine because you just joined in, but okay, so probability is here, it's just a formula, right? So we'll use a lot of formula. Like, what is the formula of percentage? A by B into 100, right? Something similar. There's a formula here. Probability of A given B is the probability of both happening and probability of just B. And how did we divide this is similarly, like, for example, if at all probability of B, when we are trying to do it, which means probability of a passenger being male. So how do you do that? Like, how do you generate the score? Let's say you got 30 out of 100, right? So how do you do take out the percentage or the chances? So you're going to do equal to 30 divided by 100, right? So that is how you get it, right? So this is how you do it for a percentage. But when you're calculating for probability also, you're going to do here the numbers are given in the cross table, which is a table that got generated here, right? So that should not be a challenge. Yeah, I think Sivakumar said that. I think that's the part of community. You have helped others also in 12th CBSE book chapter 13 probability. I mean, that's very precise. Probability given clear example, right? So let me see if I can share the screen, or if it is there in the chat, but people who are watching us on social channels will not be able to see it, right? So let me stop share. I'm going to share it here. So this is what Shivakumar sir shared. What is conditional probability? Up till now in probability, we have discussed the methods of finding the probability of events. If you have two events, right, this is where it's at. From the same sample space, does the information about the occurrence of one of the events affect the probability of other event? I think so. What the CBSE textbook is telling here is, if you have two events from a sample space, so does the information of occurrence of one event, so will one event happening of one event affect the probability of other event, right? So now if you go by the example of Thank you so much, Shivakumar sir, for sharing it. So thank you so much. So if you understood this example of India winning and Virat Kohli hitting a century, is there conditional probability? Is there a chance of an event occurring given the other event will also occur, right? So that is how it goes. Yes, so Vinita, I think you have answered Ritesh's question also. So now I think now Ritesh, coming back to your question, since these are two independent events, can we say A intersection B is P of A into P of B? Basically here when you say into, is it intersection or a multiplication into Ritesh, right? So dot product. Okay, so I would, if I were you, I would do it multiplication. That's what you're saying. We can do that. So Ritesh, I think you can just go ahead and multiply and see if that is how the result is coming in. So I'm going to park your question towards for the end, right? So I'm going to make a note of it, right? Because it requires a bit of thinking, and I do not want the flow to be broken. So let me go ahead. I think that should be fine, right? Okay. Great. So I hope, Praveen sir, if there's a little confusion, it's fine because you're parachuted into the session. Do not worry, just follow along. And as we go forward, you'll understand it more clearly. But do not think that because you have not seen the previous sessions, you'll not understand this. So some of these are very new to all of us, right? So the other people also, right? Great. So now this is how we have understood. The same thing we are going to do over 2 or 3 examples. And that is all about the Bayesian statistics, right? So there is nothing more here. We'll see a few more examples and becomes clear, right? So a little history, James has put in here for us, which is who was Bayes and why do we care about Bayesian statistics? The file is with you. You can even go ahead and read about it. So there's this person, Thomas Bayes, so and so year, and he was an English statistician. So he formulated this Bayes theorem, but he did not publish it thinking that maybe it's not a great idea, right? But then later on, other people picked in, right? So like there was Laplace who developed on the Bayes rule in the current format, right? So many times happens. Even James sir explains that sometimes we think our ideas are not good, we do not publicize them, but sometimes they are good, and other times we are very sure about things that could be bad ideas, right? So that's how this was, the little history about that. Now Bayes was working on a specific problem. This is also a little history, which was more in 17th century, like back then, 1700s. It was the challenge was more on was God existence and what is the dependency of all the events happening on science or God. So that kind of a situation was happening, and that is where this was being developed. So you can read about it, right? So now let's understand this in a deeper way, right? So till now we have understood that P of A given B, meaning the probability of A occurring given the probability of the other event, is probability of both happening together and divided by probability of B. Now, because A and B, probability of A and B happening together or probability of B and A happening together is same, right? You can write it both ways, right? So now what we have done here is probability of B happening with A can also be written as now probability of B given A into probability of A, right? So do not be confused. Let me go ahead and explain this. Now, probability of A and B can be written as probability of B and A. So I'll not be able to write the intersection from my keyboard, so I'm using AND, but it is intersection, right? So now by the previous formula, probability of B, B and A. So basically both are same. Probability of A and B happening and probability of B and A happening is same, right? So now if we want probability of B given A, it would be probability of B and A divided by probability of the denominator, right? Which is probability of A, right? So I hope you understood that. Let me go ahead and do that, right? So the probability of B and A divided by probability of A, right? So if you're clear this, that is fine. Now, what is that they have done here is, now probability of only B and A happening is probability of B given A into, you just send this denominator to here, right? Which is the same thing. Right, so this is what they have done. So what they have done is they've replaced instead of A intersection B, they have replaced the probability of B given A into probability of A by probability of B, right? So if you understood this, what we have done here, type U in the chat box. So what they have done is, because, let me remove this. Yeah, thank you so much. Thank you, Ritesh. Thank you. Okay, sorry. I think my internet just, yeah. So, okay, sorry. Am I audible now? If I'm audible now, type A in the chat box. Okay, I don't know till when you were able to hear me. So I'm just going to share my screen again and yeah. Yes, so thank you so much, everyone. So I was just explaining probability of A given B was probability of A and B by probability of B. Now the probability of A given B is, you just replace this here, probability of B given A into probability A of A by probability of B, right? We are just using simple mathematical substitution, right? So I hope everybody understood it, right? So now we are going to use this as we proceed forward. Right, so there's a small example here, which is the cookie problem, right? So the question is like this, right? Suppose there are two bowls of cookies. Okay, so now we have seen one Titanic example with this simple form of base formula. Now we are going to use the new formula that we have derived, right? Suppose there are two bowls of cookies. Bowl 1 contains 30 vanilla cookies and 10 chocolate cookies, and bowl 2 contains 20 of each, right? So now I'm going to write it here. Now say probable, the bowl 1 contains, bowl 1 contains 30 vanilla and 10 chocolate. And similarly, bowl 2 consists of 20 vanilla and 20 chocolate, right? So this is what is clear. Now suppose you chose one of the bowls at random, right? Now okay, so people who have joined just now, I would request you to mute. Yeah. So now let's just say, now suppose you choose one of the bowls at random, right? So that bowl 1 and 2, you chose one bowl and without looking, right? So you just randomly picked and selected a cookie at random. So the cookie is vanilla. So what is the probability that it came from bowl 1, right? So the question here is, let's say you did not see what bowl you're choosing and you just picked and randomly and the cookie is vanilla. So we want the probability of cookie being vanilla and it coming from bowl 1, right? So if I tell you, if you are talking similarly like Titanic example, you're talking to a person and telling him, see, in that box there are 2 balls, you will not be able to see the balls, you're going to pick one cookie. So if it is vanilla, the probability of it being vanilla and it being from bowl 1 is so and so percentage. So I'm going to tell you that, right? So for example, if let's say if it was randomly say 25%, I'm giving an example. So if he takes out 100 cookies like 100 times, the same thing 25 times, the chances of it being from bowl 1 and it being vanilla is 25, right? So this is what we are going to get, that probability. Now we are going to generate that. 25 is not the number, so we'll try to understand that. Okay, so the cookie is vanilla and it came from bowl 1. So what is the probability that it came from bowl 1? So this is how you can use Bayes theorem to get more detailed probability. So you might have a question, are we studying statistics or data science, or why do we have to learn about Bayes? Because you can see towards the end in the case studies also, it is also something that is used in spam filtering, right? So there are case studies listed out. You can also go through that, where it is used in many other places also. So we'll just try to understand a simple example. So we want the probability of bowl 1, the cookie being from bowl 1, given it is vanilla, right? So now how do we compute that? So we are going to use, now if the problem statement is clear, type C in the chat box. Right, so if you understood the problem statement, yeah, thank you so much, Ritesh. Thank you, Vinita ma'am. Thank you, Sivas. So now what we are going to, Bayes rule again, probability of A given B is probability of B given A into probability of A happening and divided by probability of B, right? So we are going to use, give me a second. Sorry. From the let's make it relevant, and we have this, the probability of it being from bowl 1, right, and given vanilla, right, is probability of the denominator, the probability of it being B1 is same, so it has been written here and there, right? So is B1, so A is B1, V given B1. So you have understood this, right? So we are going to compute this. Okay, so let's go ahead and do that. So people who have already gone through the lecture revision, so okay, right. So what we are going to do, probability of it coming from bowl 1 given it is vanilla is equal to probability of it being vanilla given it coming from bowl 1 into probability of the first one, probability of this. Okay, Siva sir says my voice is breaking. I hope it's not. Yeah, if my audio is clear, type in the chat box. Okay. So what I'm going to do is, yeah. So let me turn off my video temporarily. Okay. So let me just check my Wi-Fi. Okay, so so sir. So what I'm going to do is I'm letting, I'm turning off my video and tell me. Okay. So now what I'm going to do, I'm going to say, given by going by the example, probability divided by probability of V, right? So let's get each of, so this is what we are going to compute, right? If this is clear, type C in the chat box. Yeah, thank you, Dinesh. Okay, so now let's come from here. So let's what we are going to do here is we are going to do a cross table by ourselves. Chocolate and it being from bowl 1 and it being from bowl 2. Okay, so give me a second, people. So what I'm going to do is I'm just going to switch my Wi-Fi. Really sorry for that. Right? So right? So if my audio is clear now, type A in the chat box. Sorry for the people who have joined and if my audio was not clear. Yeah, okay. Thank you so much. Seems fine now. Okay, sorry for that. So now we are doing a cross table by ourselves, right? So now we are going to understand this, right? So in the bowl 1, we had 30 vanillas and 10 chocolates. And in bowl 2, we had 20 vanillas and 20 chocolates, right? Cookies, basically, right? Now we have done our cross table by ourselves. In our Titanic example, we use the crosstab function. Okay. Now what we are going to do here, because we need to generate this, we need all of this, right? So now probability of B1. So let's one variable out of this is probability of it coming from bowl 1. So what is the probability? We have two bowls. The probability of it coming from one bowl is how much? Anybody on chat? You have two things to choose. What is the probability of it being from bowl 1? Can anyone? Yes. Okay. So I think Vinita ma'am, you might want to rethink. Yeah. It is 1 by 2, right? This is 50%. It's like heads and tails only. The cookie being from one of the two balls is half, right? So I'm going to do the same. I'm going to say 1 out of 2, which is 50%, right? Yeah. So Siva sir, you were right. Thank you so much. So now I hope Vinita ma'am, this is clear, right? If this is clear, you can see in the chat box. Yeah, okay, great. Thank you, Suraj. So thank you, Suraj. Now what we are going to do, now we got 1. So we are closer, we need other 2. So now we need to know the probability of it being vanilla, right? So now, how do you guess that, right? Now, if you see in our cross table here, what did we do is like, it was all available. So now probability of it being vanilla is, you basically have to do a sum of, what to say, sum. I'm just trying to make it simple. The sum of these two, right? And similarly, because it's a cross table, right, I'm just going to say equal to sum of, right? So in both the bowls, we have 40, 40 each, right? Now, if we want vanilla, the probability of it being vanilla, can anyone give a guess? Right? What is the probability of any cookie being picked up being vanilla? So Sivakumar, so vanilla is 50, total is 80. So probability of it being vanilla is 50 by 80. So this is what Sivakumar sir has told. So how many of you agree with that? Like type A in the chat box. So I'm going to, mention it here because people on social channels will not be able to understand. Thank you so much, sir. Okay. That's great. Thank you so much, sir. So let's go ahead and see that. So what Suraj sir, so Shiva sir, you have mentioned is the probability is of it being vanilla is all being vanilla, which is 50 divided by 80. So how did we get vanilla? So in bowl 1 30, bowl 2 20. So we have 50 divided by total 80, right? So others also who are clear, like, so I'm going to say 50 by 80, which is 5 by 8. and which is 0.625. Thank you so much, Siva sir. So I think that is going well for you. So others, I hope it is clear for everyone. Everyone else, apart from Suraj sir and Praveen sir, who said agree. So yeah, thank you so much, Ritesh. Praveen sir, you understood it. So I think you are getting it slowly. So I think that's great. So now we are only missing only one thing, which is probability of it being vanilla and coming from bowl one, right? So now it's a little tricky now. Yeah. So who's going to give me the answer for this? Probability of it being vanilla and coming from bowl one. Okay, Anita ma'am has given the answer as 30 by 50. So I'm just going to say ask others. So if others agree or you have other proposition, you can put it on the chat. 3 by 8. Okay. So what Ritesh is saying is it coming from bowl one, it being vanilla, is 30 by total 80. Right? That's what Ritesh says. So anything, sir? Siva sir, you can take a check. Okay, Tejinder sir. Wow, I think I'm loving an answer from Tejinder sir. Very recently you have joined, and I think I'm kind of yeah. So Vijay sir, 30 by 40. Okay, right. So I think there is a good amount of mixed views here. It is either 30 by 40 or 30 by 80. Right. Okay. So let me come here. The answer is Vijay and Tejinder sir, you were right. You can see that the probability of vanilla given bowl one coming from bowl one is 3 by 4, right? So this is the probability of getting a vanilla cookie from bowl one, which is 3 by 4, 30 by 40, right? So it is easy. Let me come here. So Anita ma'am, I understand what you did is total vanilla, which is 50, and you did 30 by 50. But here the question is it coming from bowl one. So you need not take it from bowl two. Okay. So you can, so this is not the right one. So others who have said like 30 by 80, I understand what you have done here. So you have taken 30 by the total number of cookies, right? But then we're not talking about anything up from bowl two, right? So we're only talking given bowl one. So 30 out of 40, right? So that is how we'll reach this, right? So we're only talking about only bowl one. So it's the bowl one is the whole universe here. We want it being vanilla from and it being from bowl one, right? So I think that becomes clearer now, right? So Ritesh, have you got it? Yeah. So we are rethinking our approach. Now you said earlier 30 by 80. Now, if you are able to rethink, it is 30 by 40. I hope that is clear. So Anita ma'am, thank you. Gopal Raju sir, thank you. Ritesh, I want a thumbs up from you. Yeah, Tejinder sir, thank you so much for your input. Because I'm really appreciating it. No, Ritesh. So here, what is 80? So 80 is count of bowl one and bowl two, but we are only looking at bowl one, right? So I think that is where you might be thinking that the 80 is from only one bowl, right? So it's not. Yes. Okay. So Ritesh, I hope now it is clear. Only bowl one, so 40. Okay, great. I think that is clear. Okay, let's move forward. And now I'm going to freeze this. Okay. Let's say I'm going to say equal to 30 by 40, right? Which is 30 divided by 40, which is 0.75. Now we've got all of these. Only thing that we require is putting in the equation. Now let's go ahead and do probability of V given B1 and probability of B1 divided by probability of V, right? It's 0.6. Okay. Now let's check. Are we right here? It says 3 by 5, which is something similar to 3 divided by 5. 0.6. Okay, so we are right. So now what is your inference from whole of this exercise is, in this universe, like in this particular set where you have two bowls, 30 vanillas and 10 chocolates in first and 20 each in second. If somebody without seeing goes and picks, like, you blindfolded him, you or him or her, somebody is going to choose one from it, it being vanilla, and it being from bowl one, right? So it being vanilla is easy, right? You're going to say 50 by 80 and you'll be able to tell that, that's easy. But it being vanilla and it being from bowl one is 0.6, right? So which is something that you'll not be able to directly see from the data, but with this equation based theorem, you are able to calculate that. So there's a 60% chance that it is from bowl one and vanilla, right? Because more vanillas in the first one, right? Okay, so how many of you understood this example? If you understood this, type U in the chat box. Great. Thank you, Ritesh. Thank you, Gopal. Thank you, Gopal sir. Thank you, Shivakumar sir. Yeah, so it's team contribution. Everybody helped me, get that, right? So now, similarly, you can go, we'll go ahead and understand a little bit more. So the big idea that comes out of this is, whenever you have initial, your assumption plus new data, right? For example, earlier we said 30 by 50 or something, right? So the initial, there was some idea that you had, then new data got added and you have an improved belief. So this is how it goes in scientific, frameworks. And Bayes' rule was important in many other places also. So if you've seen that movie of Alan Turing, where I also forgot the name. Even James sir mentions it in the session, where it's not Beautiful Mind. Yeah. So if you remember, no, Beautiful Mind is a different one. This, okay. So is it Beautiful Mind? No, I think it's a different person. Yeah. Okay. So I will take it up in the end, right? So yeah, it's on my mind. I'm not able to. Yeah. So this also, Bayes' rule was also helpful in cracking the code for the German Enigma, and many other theorems like that, right? So that's how it is, right? So now Bayesian statistics seem so great. Why do people have a problem with it? Yeah, so a little bit it was explained in theoretical sense, right? What happened historically and all. So you can go ahead and read it, right? So what is the challenge and all, right? So it's not very relevant to our present exercise. Okay. Imitation game. Suraj, thank you so much. Yeah, so the actor from Doctor Strange, which is I don't remember the name of the actor also. Yeah. Great. So it is the imitation game, Benedict Cumberbatch. It's also in the Sherlock's series. Thank you so much, sir. Right. So now we'll see this in action. Now there's a name for each one. So there's a name for each variable, right? So whenever you say the probability of A given B, it is called posterior, and probability of B is called the evidence. Probability of A is called prior. Probability of B given A is called likelihood, right? So what questions, like whenever and probability is something very important that when it comes to interviews, James sir explains, right? So, and the questions would be like this. In the question, the evidence is 30% or 30, right? So, and the prior is 20, right? And they'll ask you posterior or likelihood, right? So they'll give other things. So it's also good to remember the names, like what is posterior, what is likelihood, what is prior, and what is evidence, right? So I hope this portion is clear. There's a name for each, equation set, right? So now it's also mentioned here, the posterior probability is the probability of the event of the interest happening, whatever interest we are seeing, like cookie being from bowl one. So the likelihood is what we consider the normal hypothesis testing. The prior is our prior knowledge about the outcome. The evidence is the evidence from a sample or experiment, right? So these are, the same, names for the same things. Okay, I hope that is clear. The another way to think about this is probability of, when you say A given B, so it is like this: probability of hypothesis. A is a hypothesis given the data of B is equal to probability of data given the hypothesis into probability of hypothesis divided by probability of data, right? So because you'll not have the probability of hypothesis given the data, you have the other things, probability of data given hypothesis, right? So hypothesis and data in some situations could be also used in place of posterior or likelihood and all, right? Yeah, so it's not like both of these, like say probability divided by probability of data, which could be the situation where you have the data available, right? I hope that is clear, right? So this is how it's also called in other ways, right? So this is what we have covered till now in Bayes' theorem, right? So if till now you are clear with all of this, right? Type C in the chat box, because we're going to conclude our session. We'll just see a few more cases. Thank you, Ritesh. Thank you so much. People who are watching us on our social channels like YouTube, LinkedIn, Facebook, you can use the chat option. Thank you, Praveen. Thank you, Surat sir. Right. So now we have covered all of these. Now, there's a lot of online data about where it's being used historically also. One of such example is here, right? So which is Bayesian search theory. In that, what the team was trying to access is finding a submarine which got wrecked in an ocean, right? So while trying to search the submarine, there's also this particular theorem was also used, right? So there was this one USS Scorpion, and this particular submarine was serving the United States Navy, and this Scorpion was lost under mysterious conditions on 22nd May of 1968, killing all 99 crewmen, right? So then they tried using the Bayesian theorem to understand, right? So we're not going to calculate all that, but this is how they have calculated, right? So how do we try to assess the wreckage given one other conditions, right? So the probability of the submarine being in one spot given we can find it is equal to probability of finding the submarine in that spot into probability of it being in the spot divided by probability of finding that submarine, right? So they have put in all those portions in the equation. They might be using other mathematical derivations and all, and they were able to use it, right? So here we're not going deeper into it, but it is very good to know that such simple equation or theorem was used in such complex problem where you're trying to search for a submarine, right? The probability of finding it, right? So similarly, other things also like disease testing, right? So there's this one data set. It's very similar to the cookie example. You can also do it. So we have our cross table, diseased, meaning let's just say either he contracted the disease or is no more, like not diseased is good or not, is alive, right? So tested positive and tested negative, right? So for example, if you have a data set like this, there were 99 people who tested positive but are no more, and there are 99 people who tested positive but are alive, right? So this is the total, and there's one person who tested negative but no more, and there are 9,801 people who are still alive and tested negative. So there's a whole data set here, right? Similarly, like cookie example, the data set is there, and if you want to know probability of A given B, like let's just say the probability of disease, being he deceased is A, and given the probability has positive test is B, right? So the probability of A B given B is the probability of a person being deceased given he tested positive. So how do we do that? We use the equation and the probability of B given A, and everything you are going to calculate in the same way we did for our cookies example, and you'll get the probability of A given B, meaning the probability of person being deceased and while he tested positive, right? So this is 50%. So there's a 50% chance that the person might get deceased if he got tested positive, right? So now it becomes easier for statisticians or sometimes doctors to take a decision to whom to operate on if it's a critical situation. It should not be the actual situation, but like, a lot of other things, other decisions can be taken, right? So if somebody's trying to save, a few people out of all of them and trying to, do their best, having an assessment like these helps, right? So from the table, we can also see that given a positive test, the probability of disease is 99 by 198, which is 50%. Okay, so I'm not going in detail of this because I would want you to go ahead and do, and each of this, everything is put up here. Go ahead and put the table here and come up with the equation, right? Come up with the probability of A given B, right? So I hope each of you are sure that you will be able to do it, right? So how many of you are going to attempt it? Type A in the chat box. Thank you, Prashant. Thank you, Surya. Thank you, Gopal sir. Yeah, so this is a very simple one, right? Thank you, Anita. Thank you, Shiva. So, and now a few other complex places where it is being used. It's all mentioned. We're going to conclude our session here. So I'm just going to explain this. It is written out in detail here. So what we're going to do is, if you see the Bayesian spam filtering. So now how spam works is, there are a set of words which are marked as spam, right? And if there is one word that is spam in that message, it checks if the whole message could be spam or not, right? So this is how the Bayesian theorem is used in trying to see if the message is spam, right? So the probability of a spam word and given the whole message is something similar. You're going to map it, and based upon that, spam filters, right? There are online spam filters, right? I'm just going to give you an example. Filter check, right? Right. So there are ways where you can send a promotional mail to one particular email ID, and based upon the spam filtering algorithm and all those things, it will tell you, right? So you have to send a mail with, like, say, a promotional email, right? So you can send it to this particular email ID and it will tell you if it will pass this spam filter or not, right? So the logic of that uses this, the Bayesian spam filtering. So that is how you'll. So I'm not going in detail of it, but if you need to understand that in spam filtering also it's being used, right? So if you have understood this, type U in the chat box. Okay. So now it is like simple keywords. Like if you see in the message by all of these things, some words, like let's say it's an offer, such keywords, when you spend at large to many people, it gets marked as spam and it does not go to the inbox and goes to the spam, right? So if you see this example, let's say watch free anime downloads, right? So if you tweak that words, if this particular thing will go into spam because few of the words are there in the spam filter, right? So see you at the house will not be spammed, but when you say sell your house now, right? So there is some sales angle to it and some keywords which are marked as spam, and that particular message will be marked as spam, right? So all of this is being done in the same example, right? So more examples for you to understand. I would request you to go through the session, go through the Collab file and understand it in a deeper way. Okay. Yeah, Suraj says, yeah, paraphrase to escape being marked as spam. Yeah, many people do that. Right. So other way is to keep your messages short, right? So when you're trying to expand it, spam filters will, the chances of the spam filter, the probability of it getting into spam increases. That's a trick. Yeah. Great. Thank you so much, Siva sir. Okay. So I hope this session was valuable even to the people who have joined recently. Thank you so much for all the feedback. What I would request is, I would request any of you to, unmute or come on video and let us know, like, what do you think about today's Bayesian, this topic, and how do you think it is helping the whole world, or it will be helpful to you, right? So it will be result sharing. So what before the session, what knowledge you had and what difference you'll have now, right? So I'm going to ask anyone to come up and share your result. Yes, Anil, I'm going to answer that. Yeah, so anyone here? So I'm going to, you can turn on your video. I hope you can turn on the video and you can come. So anyone who wants to share, type me in the chat box. Yeah. Ritesh? Yeah, so you can just formulate. Okay.
Can you hear me?
Yes. Just give me a second. You are audible. Great. Yeah.
Okay. Yeah, sir. It was like a bit interesting. Like, honestly, it's not that interesting in my opinion, because like all you have to do is like you already have a like a like equation, like a formula is there, and you just have to like plug in all the values inside that formula and get the answer. So in my opinion, it is not very interesting, sir, but I think it's like very like helpful, like as you like explained, like it's help to see spam mails, and it has like other like applications as well. So it was explained like by L by you, sir, as you always do, but in my
I
opinion, it's
understood.
not most interesting. Like
So basically, yeah. So because it was more mathematical than Python. So I
yeah,
hope
sir.
I understand. Yeah. So, but thank you for sharing your, because we all have our viewpoints, and thanks for sharing your viewpoint.
Yes, sir.
Basically,
Thanks.
it is the utility of this particular theorem is more important than
Yeah,
being interesting
exactly.
is what I understand. Thank you so much.
That's
Thank you so much.
okay, sir. Thank you. Thank you for
Yeah.
the class.
Yeah. Anyone else who wants to share their result? What is your takeaway? Uh, what difference this particular session made in your understanding of the concepts? Sivakumar said that is fine. Maybe if possible, if you can unmute and share, that's if that is possible only. You can let us know. Anita ma'am.
Sir, so like actually have one more question I have, sir. Am I audible?
Yeah, you are.
So like where else is this Bayes theorem actually used in AI? So like for spam, it's used. It has application over there. But like
Yeah, so
where else?
basically it is not directly used, it is used in combination with other machine learning algorithms. So there is an algorithm and you pass it through the probability of an event happening given other event. So that is how some algorithms also try to assess, right? So what could be the probability of this event happening, and based upon that they take a smaller decision, right? So we'll cover about that as we come there, but for you to understand now, the machine algorithm, the machine learning, it can, sometimes it will come to a point where it has to take a decision, should I do this or do that? But in such places, Bayes theorem will come handy. Based upon a few probabilities, it'll try to understand, okay, let me go ahead and do this.
Got it, sir.
Could
Okay.
be wrong. Yeah. In
Okay, sir.
combination, it is used. Yeah. So yeah, so Raja sir says, you already studied it, and maybe Bayesian AI model, right? Maybe Raja sir, you'd be, better person to answer Ritesh's question also, right? How it is being used in AI. So I think the keywords could be Bayesian AI model. I think Ritesh, you might want to look at that. Thank you so much, Raja sir. I think the Ritesh question is, why is it called naive Bayes? I think it's more of a nomenclature based upon something. I think the answer would be there online, because it's more of title based. I don't think I'll have an answer for that. Why is it called naive Bayes? It is interesting. You can just let us know in our upcoming session.
Okay,
so,
sir. Okay, sir.
Yeah, thank you so much. So Anil sir, in the inner circle towards the end of AI, you'll be able to find and the previous session hackathons also, right? So just in case if you're not able to identify, let us know. We'll add it onto your email. Yeah, inner circle is the piece. Today's session will also be there. Yeah, Tariq sir says, thank you so much. Thank you so much, Anil sir. Tariq says, I'm yet to start as I've joined yesterday. Wow. I was just wondering, how could I be able to meet the hackathon classes when you are way ahead in your classes? Okay. So Tariq sir, all our hackathons are going to be cyclic. So once we finish this, we'll start from beginning again, right? So one thing that might be helpful is that, and the hackathons keep happening. So I would request you to consider the primary lectures as the actual flow, right? You need not have to catch up the live sessions, and these happen only 3 days a week. So you can, if at all you plan on catching up, you can also do catch up. Many people, like for example, if you have completed like 4 or 5 sessions of the actual course, you can parallelly do both, right? So you can actually do the hackathon also and parallelly continue your flow, right? So you can complete both as well, right? So that would be helpful. So you need not have to catch up immediately, right? Slowly you will. Tejinder sir, please explain how to join. Please send a link to Inner Circle. So yesterday's Inner Circle, you can see in your email, the YouTube, there is a box with the image of JN sir with a play icon. You can click on that, it will take you to YouTube, right? It will also be in Inner Circle Vault. It is on your Teachable, sir. It is on your Teachable. So I think Ritesh, Raja sir answers your question naive because it's naively assumes that the events A and B are statistically independent, while actually they may not be, right? Okay, I think there's a little thinking that you can do about it. Thank you so much, Raja sir. I think there's a lot of insights we're going to get from you as we proceed, sir, right? Even if it is just a search also, it is still fine because, interaction is more important here. Gopal Raju sir. So Gopal Raju sir, maybe you can unmute and just share the same result quickly, a little about that. If that is possible, that is fine.
Yeah. Earlier I don't know much about this Bayes theorem. Now I had an idea now.
Okay.
So, yeah, I understood better.
Yeah, thank you so much, sir. So you're catching up all the sessions from the beginning, sir. So how is that? How is it going?
Yeah, I covered all the Rajiv sir sessions, but the initial sessions not covered this.
Understood. So basically, you're catching up with the intermediate complex concepts covered by Rajiv sir, and the big not covered. So you are doing both. That is good.
Yes,
yeah. Thank you so much. Thank you so much, sir.
Please share me the Mighty network link. I didn't receive any mail.
Yeah. So basically, I would request to mark directly in chat along with your email. So all the people who have not received Mighty Networks, because some people might be in bronze and some people might be in silver. So there are 2 different community links that come up. So I request everyone to directly send email. So I'll send it to you.
Okay, sure.
Yeah. So Ritesh says, thank you, Radha sir. Thank you so much. And Tariq, do we also have recording of hackathon? Yes, Tariq. The recording of hackathon will be available in the Inner Circle, Inner Circle Vault. Okay. Yeah, Gopal sir. Okay. Suraj says, I recall Bayes theorem from. Yeah. So when I came across Suraj sir, my understanding was also the same. So I saw it while I was in college or previous. So context-based examples were interesting. Yeah. Thanks to James sir. Okay. So I've received your email, Gopal sir. So making a note of it. Anil sir. Out. Okay, so people who are, so we are going to conclude our session. Thank you so much for joining, and I see that it is valuable for most of you. Thank you so much. Tejinder sir, you might have to ask your question again because not able to understand. Yeah, so Siva sir, it is j@pixeltest.com, correct? Yeah, you can leave your email ID also. That's also fine. We'll start with orientation, Tariq. Yeah, that's great. Wow, I think Ritesh, I think you should put this on the community. It's a good resource. If you feel that is fine, everyone try practicing probability problems at brilliant.com. It's helpful in interviews. I would request Ritesh to please go ahead and put it on the Mighty Networks. Many people will find it useful. Yeah, so great. So, Raja, I'm also going to send the links to you. Inner circle will be in your teachable, sir. So I'm going to share my screen and show it to you. And post that, we'll conclude our session. Okay, that there is naive by ease. And yeah, so if you go to your teachable, okay, so let me just show the inner circle. You'll find a few courses on you, and out of that, you're going to pick inner circle. Let me show that. Yeah. So people who are clear, maybe you can drop the call. So I'm just going to share, safely drop the call. Yeah. So this is how the inner circle looks like, sir, on your teachable. If you're facing a challenge, you can reach out to me, right? So in here, you can see that, Rajiv sir's lectures are here. And below that itself, you'll find, the recent one also. Towards the end, you'll be able to find the hackathon recordings as well, right? So inner circle vault is where you need to find them, right? So latest ones will also be updated there. Thank you so much, Ritesh. So thanks everyone for joining in, and I hope this was valuable for you. Great. Okay, then we'll call it.